Video I'll be talking about velocity reduction method and sizing round air duct based on recommended and maximum velocities for residence. Velocities reduction method is a method which is used for sizing air ducts. So by using this method is gonna allow us to select suitable velocities for sizing ductwork. So sizing air duct by using velocity reduction method, the velocities will remain constant for entire the system, and it will result to have a lower friction loss value and larger duct size compared to the equal friction method. So as I mentioned earlier, the velocity reduction method is used to select suitable and lower velocities, so which will allow us to select a larger duct size. So as the velocity gets lower, the size of duct gets larger. So in a minute I will be doing some examples to find the required sizes for a duct system by using the design airflow rate of the system, recommended and maximum velocities. Based on ASHRAE 1989 Handbook of Fundamental, the recommended velocities for residence main round duct is 900 FEM and 600 FEM for branches round duct, and the maximum velocities for residence for round main duct is 1200 FEM and 1000 FEM for branches round ducts. Let's say we have a design airflow rate of 1000 CFM and we have been asked to find the diameter of main round duct and whole branches at recommended design velocities of 900 FEM for main duct and 600 FEM for branches. As you can see, the airflow rate of 1000 CFM flowing through a main supply duct, and there are 5 branches: B1, B2, B3, B4 and B5. So we have 300 CFM for B1 and 300 CFM for B2, and then 400 CFM for B3, and again we have 200 CFM for B4 and 200 CFM for B5. To find all these branches and main supply duct diameter, the first step is to find the area of duct by dividing the design airflow rate over air velocity, and then to find the diameter of duct, square root 4 times area divided by pi and times 12 inches. To find all these branches and main supply duct diameter, the first step is to find the area of duct by dividing the design airflow rate over velocity, the square root 4 times area divided by pi and then times 12 inches. Let's start with main supply round duct. So 1000 CFM divided by 900 FEM square root 4 times 1.111 divided by pi times 12 inches, that give us a diameter of 14.26 inches. 300 CFM divided by 600 FEM square root 4 times 0.5 divided by pi and times 12 inches, that give us a diameter of 9.5 inches. For B3, the same process, 400 CFM divided by 600 FEM square root 4 times 0.666 divided by pi times 12 inches, that gave us a diameter of 11.05 inches. And for B4 and B5, also the same process, 200 CFM divided by 600 FEM square root 4 times 0.333 divided by pi times 12, that gave us a diameter of 7.812 inches. As you can see, these are all required sizes that we have just calculated them. 14.26 for main deck, 9.5 for B1 and B2, 11.05 for B3, and 7.812 for B4 and B5. So if you compare these sizes with a deck sizer result, that is gonna give us the same result as the deck sizer. As you can see, on deck sizer, we just sized with the velocity reduction method. The friction loss value is less than 0.1, so 0.08 for main supply deck with a diameter of 14 inches and about 1/4, and friction loss value of 0.06 for B1 and B2 with a diameter of 9.5 inches. And next one, a friction loss of more than 0.05 for B3 with a diameter of 11 inches. So these are sizes and friction losses that we have just calculated them by using recommended velocities, which are the same result as the deck sizer based on recommended velocities. So that's it for today. Thank you very much for watching this video.